Hello, everyone. We're Team IGT, and our project is the ShowController replacement. First, I would like to introduce our technical directors, Raymond Leland and Eric Hanley. They both graduated here from URI in 1993 and 2005, respectively. Our team consists of 2 electrical engineers and 1 computer engineer. I'm Kartik Mahanti. I'm an electrical engineer. Andy Yu is an electrical engineer. And then Nathan Campana is a computer engineer. Before we get into our project, I would like to talk a little bit about our sponsoring company, IGT. IGT is headquartered in London, England, with operating offices in Rome, Italy, Las Vegas, Nevada, and here in Providence, Rhode Island. They're the world's leading end-to-end gaming company, and they provide lottery machines, slot machines, and other types of gaming technology. So if you walk into a store and see lottery displays, or if you walk into a casino and see those gaming machines, there's a chance those machines were made by IGT. The ShowController is a video controller unit, or VCU, and it acts like a dual display media player that can also act as a headless terminal to eliminate the need for touchscreen lottery displays. But most of the time it's used for digital signage for lottery advertisements that you would typically see at any retail store. The goal of this project is to update the current version of the ShowController with the new and improved version. The anticipated best outcome of this project is dependent on the initial buy versus build analysis, which I will get more into depth on later. But if a buy option is chosen, the anticipated best outcome is to buy a commercial off-the-shelf device and integrate it with IGT's platform and digital media software and have it ready for the market by April of 2023. However, if a build option is chosen, then the anticipated best outcome is to develop a prototype device, integrate it with IGT's platform and digital media software, performance test it, and transition it to IGT's engineering team by April of 2023. So here is a summary of all of our team's technical accomplishments so far. We all performed the buy versus build analysis, and we organized our findings into a document. We also did research on key components of the ShowController, such as CPU, the GPU, RAM, and others, and we organized the specifications of these into a spreadsheet. We also performed benchmarking tests on the existing ShowController and also on one of the new CPUs that we chose using a prototype board. And we organized this benchmark data into a spreadsheet as well. Digital signage is essential to lottery systems as they provide the players with key lottery information. The new ShowController will be one of IGT's products that can be used by retail companies that need lottery displays on different monitors at the same time. Now I will talk about my specific technical accomplishments to this project. I, along with the others, performed the initial buy versus build analysis. Also, everyone on the team did component research for different components of the ShowController. But for me, I focused my research on the CPU component, and I recorded the data and specifications for the CPUs chosen into a spreadsheet. But first, let me explain the buy versus build analysis a little bit more. So we were trying to determine whether we should purchase an off-the-shelf device or build the device from different components. We determined that there were no commercial off-the-shelf devices available that matched the requirements needed for the new ShowController. So we decided that the build option is best moving forward. That's when we moved into component research and when I moved into the research of the CPUs. But first, let me just explain what a CPU is. CPU stands for Central Processing Unit. It is considered to be the brains of the computer and is in charge of processing all the computer's tasks, which is why it's so important to the research in building this new ShowController. It is contained in the motherboard of the computer, and there are multiple companies that produce CPUs, but we primarily researched CPUs from the Intel company. Here I have provided two tables from the spreadsheet that I made to organize my CPU data. So in the column on the left, that one that is in red. That's the data for the CPU that is currently used on the existing ShowController, and I'm comparing it to the four columns on the right, which are four different CPUs that we found that could be potentially used for the new ShowController. And I recorded data from many different categories, such as frequency, cache size, and whether there's an embedded option or not. I also recorded data for the graphics aspect of it, or the GPU. By April of 2023, I plan to do further research on USB-C video implementation. One of the things we're trying to do with this new ShowController is have a USB-C video output as opposed to HDMI, and also try to finalize the hard requirements for the ShowController so that we can order the parts needed and we can actually build it. And also, we need to develop prototype for the ShowController, and also I will do the documentation on the final product. So this is a simple block diagram of how the ShowController works. Basically, this laptop picture right here you see in the bottom left corner is called a ShowMaker, and that's where you make the essentially the graphics that can be displayed on the monitors. It is then sent up to this terminal management system, which then goes to the internet or network, and Ethernet cable is used to send that data to the ShowController, where it can display those graphics on multiple monitors at the same time. Now I will pass it off to Nathan. He will talk about his individual contributions to this project.
Thank you, Kartik. So yeah, my assigned responsibilities as the computer engineer of the group are to mainly work with the actual pre-existing ShowController itself, and along with helping troubleshoot any software problems that may arise throughout the project. So once I received the ShowController, I quickly realized that everything for the ShowController is run through the Linux command line via the built-in terminal that comes with every Linux device. Because of this, the first thing I had to do was research how to navigate and use SSH. After completing sufficient research, I was tasked with getting used to how the file system is structured specifically for this device, as well as how to demonstrate a dual output display showing the capabilities of this device. Here's an example of the ShowController being displayed on the two monitors with test animations. And after I completed these main tasks that were at hand, it was time to move on to the benchmarks for comparison purposes. So for this device, it was already decided that the best choice for benchmarking would be HTML5. This is because it closely relates to the types of processes that the device would be running in a real scenario, whether it be in a retail store or a bar or anywhere you might see a TV that's running a Kino game. And because we were comparing the devices, I also had to run the same test on Ubuntu board so you can see the difference. So looking at the comparisons here, you can see that there's a huge improvement within each of the tests that we were running on both boards, with the biggest difference being Speedometer 2.1 and MotionMark. Speedometer 2.1 focuses on the responsiveness of web applications, and MotionMark focuses on the testing of graphic systems. Here you can see Speedometer for the existing VCU, it runs at about 11.5 runs per minute. And on Atom board runs about 51, which is about 5 times faster. And for MotionMark, the existing VCU runs at 2.91, and the Atom board runs at 160, which is almost a 20% or 120, or I'm sorry, almost 100% increase. I mean, 100 times increase. On the other hand, other tests like Basemark and HTML5, they both test overall performance for each device, and here it is clear based off the results that the improved hardware can, in fact, increase the performance. So, since we are still testing hardware, we have yet to integrate any of IGT's proprietary platform firmware and digital media software onto our chosen device. but once this task is needed to be completed, I will be in charge of this task. I will also be expected to complete further testing in regards to network communications between the ShowController itself and the server that is directly wired into. Lastly, I will need to further evaluate how the firmware reacts with the new hardware and to optimize the Linux graphics stack to ensure the device runs smooth and as intended. So now I will pass it off to our second electrical engineer and who is in charge of the Ubuntu board testing, and you.
Thank you, Nathan. In the early stages of the project, I was working alongside my teammates to research components and viable devices that fit the requirement of the ShowController replacement. I was specifically looking into the specification, price, and availability of these components and devices, as this would be the major factor in determining if we move on with said products. I also looked into some online benchmarks and data sheets to determine some of the hardware component performances and used the data from there to compare with the existing ShowController's hardware. Some of these were the I/O support and the GPU and CPU performances. Then I mainly focused on the Intel x6413E prototype board and using a common distribution in Linux called Ubuntu to operate it. And through SSH, I was able to access device files on the same network and was able to also provide support to the existing ShowController. I had to use the Linux terminal commands to install benchmarks to evaluate the performance of the prototype board, along with monitoring the hardware and hardware usage and temperatures. These were some of the benchmarking tools I use. HardInfo, Phoronix Test Suite, Sysbench, Chrome Experiments, OpenWeld-GL. These are some of the benchmarking results. I initially tested the board on a resolution of 1366 by 768, which is based off one of the display defaults, as well as a 1920 by 1200, which is close to the full HD resolution the device should be running at. These are the Phoronix test suite results, specifically used GPU tests, as there's many choices from the repository, and here are the Geekbench results. These results can be used to do a further price versus performance analysis, and generally used to perform compare with other prototype board performances before we finalize on a choice. Before April of next year, I'm responsible for further benchmarking and evaluation of the potential prototype boards, finalized components, and a potential bill of materials, formal documentation of all the components used for the refresh device, and helping with the integration of the refresh device with IGT's firmware and software. This is a summary of what we have accomplished as a team: bioversibility evaluation and formal documentation, Linux software and firmware research done by all of us, key component research, organization and comparison of the specification on research components, benchmark of existing VCU, benchmarking the new prototype board with the new hardware, and organization of the benchmark data. This is some of the risks involved with this project. The biggest risk was component availability, as the supply chain could affect our component availability, and if the component we needed to use for the product was unavailable, it would affect the overall performance of the final product and us being able to complete the project. And faulty components was also another risk that could be mitigated by ordering multiple components of the same type and testing these components before finalizing the product. We'd like to thank our Capstone TDs at IGT, Raymond and Eric, and our TDs at URI, and our Capstone Director, Dr. Sunak.